Good evening, all. We will start question number 10 from this class. So, what is given? Integral I equal to integral of sine power 4 into x dx given. So, this sine power 4 is also a power angle. So, this power angle I am going to convert into a multiple angles. So, how to convert? I know that sine square how to convert. So, I am writing this function as sine square x the whole square dx. So how to convert sine square, that is 1 minus cos 2x equal to 2 times sine square x. 1 minus cos 2x equal to 2 times sine square x. Using this I am going to convert here. So sine square x equal to 1 minus cos 2x the whole square divided by 2 whole square. So that I am going to write it as equal to 1 minus cos 2x divided by 2 whole square into dx. Next I am going to take the 1 by 2 outside and then I am going to use a minus b whole square formula to expand this. So what will come? 1 by 2 will come outside, is 1 by 2 square, so 1 by 4 will come out. Integral 1 minus cos 2x expanding, so 1 square 1 will come. Then cos square 2x minus 2 into 1 into cos 2x. So 2 into cos 2x dx will come. Now again I am going to use the 1 plus cos 2 theta formula to convert this, that is 1 plus cos 2x equal to 2 times cos square x. So I need cos square x alone. So cos square x equal to 1 plus cos 2x divided by 2, but I have cos square 2x here. So cos square 2x can be written as 1 plus cos 4x divided by 2. So now we'll separate the integral. Separating means 1 by 4 into integral dx 1 by 4 into integral cos square 2x equal to 1 plus cos 4x divided by 2 minus 2 by 4 will come. So 2 by 4 into integral cos 2x dx will come. Now we are going to separate this integral. After finally we will integrate. So 1 by 4 into integral dx plus this 2 also will come outside. So 1 by 8 into first one integral dx plus 1 by 8 into integral cos 4x dx minus cancelling this means 1 by 2 into integral cos 2x dx. Now we will integrate this. Integrating this we will get x by 4. Integrating this we will get 3 the x square by 2 will come. Integrating not x dx, it's dx alone, because integral 1 in 1 dx, it is dx divided by 8 will come, that is x by 8 will come, plus 1 by 8 into integral cos 4x, integrating sin 4x divided by 4 minus 1 by 2 into integrating cos 2x will get sin 2x divided by 2 plus c. Now we can simplify. We are adding these two means 2 will be multiplied numerator and denominator. Totally 3x will come. So 3x by 8 plus multiplying here we will get sin 4x divided by 32. Multiplying here we will get sin 2x divided by 4 plus c. Question number 11 also same model. Here it is given cos power 4, that is I equal to integral cos power 4 2x given, cos power 4 2x. So for this question what I am going to do, I am going to use the cos square formula. So I can write cos square 2x the whole square into dx. So what is the formula for cos square 2x? That is 1 plus cos 2x, 1 plus cos 2x equals to 2 sin square x, 2 cos square x. So this formula I am going to use here. So now what will come? Cos square x? Cos square x equal to 1 plus cos 2x divided by 2 will come. But I am going to replace here, but it is here cos square 2x. So that cos square 2x will be replaced as cos square 2x equal to 1 plus cos 4x divided by 2. That I am going to replace here. So what will come? This will be replaced integral 1 plus cos 4x divided by 2 whole square into dx will come. This I am going to replace. Now we are going to take the 1 by 2 square outside, that is 1 by 4 will come. So taken 1 by 4 outside, remaining I am going to make as a square, that is a plus b whole square. I am going to expand that. Expanding means we will get first one 1 plus next term cos square 4x plus 2 into 1 into cos 4x, that is 2 times cos 4x into dx. Now this I can separate easily. This I am going to use this formula again. So this formula again using means cos square 4x will come. Cos square 4x equal to 1 plus cos 8x by 2 will come. So instead of the 1 cos square 4x, I need to replace 1 plus cos 8x. So I will separate the integral. Separating means what will come? 1 by 4 into dx will be outside plus 1 by 4 into integral cos square 4x can be written as 1 plus cos 8x by 2 into dx plus 2 by 4 into integral cos 4x dx will come. Now separate this, we will integrate total finally. So in 1 by 4 into integral dx plus here separating that means we will get 1 by 4 already 2 available. So 1 by 8 into integral dx plus 1 by 8 into integral cos 8x dx. You can cancel this. So we will get 1 by 2 times integral cos 4x dx. Now integrating this we will get x by 4. Integrating this we will get x by 8 plus 1 by 8 into integral cos 8x equal to sin 8x divided by 8. Similarly 1 by 2 times integral cos 4x equal to sin 4x divided by 4 plus c. Now we will simplify and write. So adding first two terms, we will get, we have to cross multiply, yes, multiply by 2 in numerator and denominator. So 2x plus x, 3x will come, 3x by 8 plus second term will be sin 8x by 64 plus third term will be sin 4x divided by 8 plus c. See that actually problem is given in power function. We converted everything into multiple functions, then we integrated. Next question. Question number 12. Very easy question, but we have to apply that identity here. So I equal to integral sin square x divided by 1 plus cos x dx. So here we cannot integrate directly, or you cannot substitute that integral directly. So what we are going to do, we are going to simplify this. The numerator I am going to write it as by using the formula. So what is the formula we have in terms of sin square? That is 2 times sin square x equal to 1 minus cos 2x. This formula I am going to use here. So 2 sin square x equal to what will come? 1 minus cos 2x by 2 will come. That also I can use, or I can use one more formula. What is the formula means? I have denominator 1 plus cos x. So this 1 plus cos x should be cancelled, means the numerator also can be written as in terms of cos x. So I am going to use the identity here, that is sin square x equal to 1 minus cos square x, that I am going to use here. So using that identity we will get numerator as 1 minus cos square x divided by denominator will be 1 plus cos 2x. Denominator will be 1 plus cos x into dx. This is nothing but 1 square minus cos square. So that can be written as 1 plus cos x into 1 minus cos x divided by 1 plus cos x dx. So I can cancel these two common factor. Now integral 1 minus cos x equal to integrating, we can separate an integral, so 1 into dx minus integral cos x into dx. So integrating dx equal to x, integral cos x equal to minus will be outside, integral cos x equal to sin x, so x minus sin x plus c. Next question. Question number 13. I equal to integral, numerator is given here, cos 2x minus cos 2 alpha divided by cos x minus cos alpha into dx. So the numerator I am going to use this formula, cos 2x equal to, in terms of cos square x, that is cos 1 plus cos 2x equal to 2 times cos square x. So why I am using this formula means denominator I have cos in terms of cos, so I am going to use this formula. Now cos 2x equal to 2 times cos square x minus 1. This formula I am going to substitute here. Similarly, cos of 2 alpha equal to 2 times of cos square alpha minus 1. Now we will replace this value in the integral. So numerator will be written as 2 times of cos square x minus 1 minus of 2 times of cos square alpha minus 1 divided by cos x minus cos alpha into d alpha dx. Now we can multiply this minus inside, so numerator will be 2 cos square x minus 1 minus 2 cos square x minus alpha plus 1 divided by cos x minus cos alpha dx. So minus 1 plus 1 cancel, this 2 will be taken outside, remaining it will be cos square x minus cos square alpha. A square minus b square can be written as a plus b into a minus b. So cos x plus cos alpha into cos x minus cos alpha whole divided by, we will get cos x minus cos alpha into dx. So minus minus term will cancel. This I am going to integrate. So integral cos x dx plus 2 times cos alpha also constant, so that will be taken outside. Many of you think that integral cos alpha equal to sin alpha, but it is not correct because cos alpha is constant, so we have to take that also outside. After that we have to apply integration. Now integrating this, what will come? 2 times integral cos alpha equal to integral cos x equal to sin x plus 2 cos alpha, integral dx equal to x will come, that is x I can multiply before or after, no problem, x plus c, that is 2 times of sin x plus 2x into cos alpha plus c is the answer. Next question, question number 14. So this question also slightly this model. So I equal to integral, numerator is cos x minus sin x, denominator is 1 plus sin 2x. So we have to use the identity, we will simplify, then finally we will apply the method of substitution. So the denominator I am going to simplify, so I'll write here, then so cos x minus sin x divided by, this 1 can be written as sin square x plus cos square x, plus this denominator sin 2x can be written as 2 sin x cos x, 2 times sin x cos x into dx. Clear? Now I am going to write this a square plus b square plus 2ab, that is a plus b whole square. So the numerator will be cos x minus sin x into dx, denominator will be sin x plus cos x the whole square. Now we check that differentiating denominator we can get the numerator easily, so denominator can be taken as t. So denominator means only inside the power. So t equal to sin x plus cos x. What is the value of dt? Dt equal differentiation of sin x equal to cos x minus differentiation of cos x equal to, it is minus sin x into dx will come. Now we replace this in the integral. So I can be written as integral cos x dx equal to dt divided by sin x plus cos x equal to t square will come. That t square will come to numerator, t power minus 2 into dt. Integrating this, t power minus 2 plus 1 divided by minus 2 plus 1 plus c. So this will be written as minus 1, t power minus 1 will come to denominator, that is t plus c. Then finally we will replace the value of t. T value equal to sin x plus cos x. So minus 1 divided by sin x plus cos x plus c. Next question, question number 15. So 15th question, what is given? I equal to integral tan cube 2x. I equal to integral tan cube 2x into secant 2x dx. So this I am going to write. This secant tan 2x can be splitted as tan square 2x into tan 2x into secant 2x dx. So I have here tan x secant x or secant x tan x. So differentiation of tan x equal to secant x tan x. So differentiation of secant x equal to secant x tan x. That secant x must be taken t, but we don't have secant x separately here, that is multiplied with this. Actually this we need to take it as dt. So if we need one more secant x, but the secant x can be derived from this tan square 2x. That is, I am going to use the identity 1 plus tan square x equal to secant square x. So from this, what is the value of tan square x? That is, tan square x means tan square x equal to secant square x minus 1, but I have tan square 2x. So the tan square 2x can be written as secant square 2x minus 1 into remaining tan 2x into secant 2x into dx. Now we will substitute the values. Let t equal to secant 2x. T equal to secant 2x. What is the value of dt now? Dt equal to differentiation of secant x equal to secant x tan x. So secant 2x tan 2x into x in the place 2x available, differentiate and multiply. So 2 times secant 2x tan 2x into dx will come. Now this will be replaced here. Actually there is no 2 here, so the 2 will be divided here. So that will be dt by 2 equal to secant 2x tan 2x dx will come. This will be replaced in the integral. So I value equal to integral of t square minus 1 into dt divided by 2 dt by 2, that is equal to 1 by 2 into integrating t square, you will get t cube by 3 minus integrating 1, that is t plus c. Now we will replace the values finally. So 1 by 2 into t cube value equal 1 by 2, t cube equal to secant t equal to secant 2x. Already 3 is there, so the denominator will be 6 will come. So 1 by 6 into secant cube 2x minus 1 by 2 into secant 2x plus c. Question number 17. Now I equal to integral tan power 4x into dx. This can be written as integral of tan square x into tan square x into tan square x dx. Now what I am going to do, one of the tan square I am going to convert in terms of secant. Already we studied in the last problem, tan square equal to secant square x minus 1. So secant square x minus 1 into tan square x into dx now. Now we will multiply this tan square inside. So what we will get, integral of secant square x into tan square x dx minus integral of tan square x dx. So this we can use the formula or we can separate it first. Actually, how to separate this means, this can be written as, if you have taken this tan square equal to tan equal to t means we will get dt equal to secant square x dx. Easily we can integrate here. So but here it is not possible to integrate easily because we don't have formula for integral tan square x. So we are converting this tan square x in terms of secant square x again. So this will be written as it is, secant square x into tan square x dx minus, this can be written as secant square x minus 1 into dx. Now we will rewrite this again, that is tan square x into secant square x dx, multiply minus inside and separate integral, minus of secant square x dx plus integral dx will come. So here what I am going to do, let t equal to tan x in the first integral alone. Second integral, third integral we can integrate easily or we can integrate directly. We have a formula for that. So we are integrating t equal to tan x means substitute here, dt value will be, you can write adjacent to it. So dt value will be secant square x dx will come. So substitute this in the integral I. So I equal to integral t square dt minus, integrating this we can get, that is integral secant square x equal to tan x plus integral x dx equal to x plus c. Now integrating this we will get t cube by 3. T cube means we will replace the value of t. T cube value equal to tan cube. So we can write this as tan cube x divided by 3 minus tan x plus c is the correct answer. Next question number 17. So what is given, I equal to integral of numerator is sin cube x plus cos cube x whole divided by sin square x into cos square x dx. Here we can split the integrals and then we will integrate it. So splitting means first term will be sin cube x divided by sin square x into cos square x, sin square x into cos square x plus integral cos cube x dx divided by sin square x into cos square x. Here I can cancel one of the sin square will cancel, here cos square will cancel. So sin by cos square, that can be written as sin by cos equal to tan, then 1 by cos will be written, that is equal to secant x dx. Cos by sin equal to, I can write cot x, 1 by sin I can use it as cosecant x dx. So integral tan x secant x equal to secant x. Here integral cosecant x cot x equal to minus cosecant x plus c. So differentiation of cosecant x equal to minus cosecant x cot x, or differentiation of minus cosecant x cot x equal to cosecant x cot x, that I used here. Clear? This is the answer. Now come to question number 18. 18th question, that is integral numerator is given that cos 2x plus 2 times sin square x divided by denominator is given that cos square x into dx will come. So the numerator I am going to use the formula. What is the formula means, cos 2x equal to, that is 1 minus cos 2x equal to 2 times of sin square x. So the minus cos 2x will come this side, plus 2 sin square x will come this side. So 1 minus 2 sin square x equal to, I can use cos 2x. Substitute this value in the integral. So numerator will be 1 minus 2 times sin square x. Already it is plus 2 times sin square x available. Denominator will be cos square x into dx. So these two get cancelled. Finally we will get 1 by cos square. 1 by cos square equal to secant square x dx. We know integral secant square x equal to tan x. So our answer is tan x plus integration constant c. Question number 19. I equal to integral 1 divided by sin x into cos cube x. So this question we have to use some different techniques. So what is that I am going to use here means denominator I have sin into cos cube, numerator I don't have any functions. If I want to divide, what is the technique I am going to use means I am going to divide the numerator and denominator by cos power 4x. So my numerator will be written as 1 by cos power 4x whole divided by sin x into cos cube x divided by cos power 4x dx. So the numerator will be written as secant power 4x divided by, here this cos cube and cos will cancel, sin by cos equal to tan x will come. Now if you have taken t equal to tan x means we need secant square alone. So one of the secant square will be remaining, so that I am splitting now. So secant square x into secant square x divided by tan x. Here this secant square x I am going to convert in terms of tan. So converting the secant square in terms of tan means 1 plus tan square equal to secant square. So I am writing that 1 plus tan square x into remaining secant square x dx, not dt, divided by tan x. Now let t equal to tan x. dt value will be secant square x dx. Now this integral will be rewritten as I equal to integral 1 plus t square divided by t secant square x dx equal to dt will come. So now we will separate and then we will integrate it now. We will separate and integrate. Separating means first term will be integral 1 by t, that is dt by t will come, plus second term will be t square by t equal to t will come, t into dt. Now we are integrating, we will get I equal to log of modulus of t plus t square by 2 plus c. So now finally we will replace the t value, that is log of modulus of tan x plus t square by 2 means we can write that as tan square x plus c, tan square x by 2 plus c. Question number 20. So what is given? I equal to integral, numerator is given that cos 2x divided by cos x plus sin x the whole square, cos x plus sin x the whole square into dx. So we have one more formula we studied in +1, that is cos 2x can be written as cos square x minus sin square x, cos square x minus sin square x. That formula I am going to use here. So I will get numerator will be cos square x minus sin square x divided by cos x plus sin x, cos x plus sin x the whole square into dx. So numerator can be written as a plus b into a minus b. So that is numerator can be written as cos x plus sin x into cos x minus sin x whole divided by cos x plus sin x the whole square into dx. So these two get cancelled. So denominator I am going to take it as t here. So denominator is what is available, cos x plus sin x, that I am taking t here. So t equal to cos x plus sin x. So dt will be differentiation of cos x equal to minus sin x. So minus sin x plus differentiation of cos sin x equal to cos x into dx, which is nothing but the numerator, cos x minus sin x dx. So that I can be rewritten as integral dt divided by t. So integral dt by t equal to log of modulus of t plus c. So substitute the value of t, what will come? Log of modulus of sin x plus cos x, sin x plus cos x plus c. 21st question, I equal to integral sin inverse of cos x into dx. So I have studied that cos x, how to write cos in terms of sin, that is cos x equal to, we have studied sin 90 minus theta. Sin 90 minus theta equal to cos theta, that I can use here. So integral I equal to sin inverse of sin of pi by 2 minus x into dx. Clear? Now this can be written as integral pi by 2 minus x into dx will come. Now we can separate an integral. Pi by 2 is constant, so pi by 2 into dx minus integral x dx. Integrating this, what will come? Pi by 2x minus integral x means x square divided by 2 plus c. Actually here we used the property of inverse trigonometry, that is, what is that means? Sin inverse of sin theta equal to theta. This concept we used here. 21st question, 22nd question, last question of this exercise. So this is a different model question. So I equal to, it is given integral dx by, denominator is given that cos of x minus a into cos of x minus b. So here what is the concept I am going to use means, I am going to use new concept. I am going to multiply by sine of b minus a in numerator and denominator. So that sine of b minus a is constant, that is multiplied outside 1 by sine b minus a. To compensate that, I am multiplying that sine of b minus a in numerator divided by cos of x minus a into cos of x minus b. That is, I need the cos x minus a, cos x minus b in numerator, so I am going to use that in numerator. Now I don't have x term in the numerator, so I am introducing x term. To compensate that, I am subtracting the x term. So that will be 1 by sine of b minus a into integral sine of, I am going to add the x and I am going to subtract the s here. So b minus x plus x minus a into dx divided by, denominator will be as usual cos of x minus a into cos of x minus b. So the numerator going to group as x minus a, then x minus b, but I have b minus x here, so I need to take minus outside here. So 1 by sine of b minus a into integral sine of, first term will be x minus a, second term I need to take minus common from these two terms, so minus taken common means I can get x minus b into dx divided by cos of x minus a into cos of x minus b. Now the numerator I can use the formula sin a minus b, sin of a minus b. So what is the formula for sin a minus b? Sin a minus b equal to sin a minus b equal to sin a sin b minus cos a sin b. So sin a cos b minus cos a sin b. So the numerator will be sin a cos b minus cos a sin b. So cos of x minus a into sin of x minus b divided by denominator is cos of x minus a into cos of x minus b, then finally dx will come. So now I am going to separate this numerator into two integrals. I have separated and written here. So first term divided by denominator, then second term divided by denominator. Now we can cancel the common terms. So cos x minus b cancel, cos x minus a cancel. Remaining terms we will write that. So sin of b minus a into integral numerator is sin of x minus a divided by cos of x minus a dx, minus second term will be integral sin of x minus b divided by cos of x minus b into dx. So here I can use sin by cos equal to tan. So the tan x equal to integral tan x equal to log of secant x, or we can use log of 1 by cos x. So log of 1 by cos x means log of 1 by cos x minus a, minus same thing integral sin by cos equal to tan, integral tan equal to log of secant. Log of secant is nothing but log of 1 by cos. So I am writing this also log of 1 by cos x. So 1 by cos of x minus b. Now we can use the formula log a minus log b equal to log a by b. So this term divided by this term. So log of modulus of 1 by cos of x minus a divided by 1 by cos of x minus b plus c. Now this cos x minus b will come to numerator, cos x minus a will come to denominator. So what will happen? This will be equal to finally 1 by sin of b minus a equal to b minus a into log of cos x minus b will come to numerator. So that is cos of x minus b divided by cos of x minus a plus c. Clear? Okay. Thank you all. Remaining next chapter, next exercise 7.4 concept and exercise 7.4 problems will be discussed in next class. Thank you.